Hi, today we are gonna take a look at this autopilot controller SEP6. On the front there is a blue selector for pitch and an orange one for the roll left to right. On the rear there is a circular connector and this thing is sealed. Oh, that's interesting. Actually, this is a synchro transmitter. So this is another synchro transmitter, and there is a clutch here. You can see the connection for the clutch. The clutch permits to link the shaft here to the synchro, and this synchro is activated using this knob here. There is a very large gear train reduction. And we have another cylindrical stuff here with only two connections. There is nothing written on the body of that thing. There is a resistance of 90 ohms. It seems that we have a kind of electromagnet inside. It's maybe a kind of electromagnetic brake. Well, that's interesting. So this permits effectively to keep in place the shaft here. We can see that there is a micro switch linked to this knob, and it is possible to energize this kind of brake here. So now the knob is linked permanently to the synchro transmitter here. And if I de-energize the solenoid, there is a reset of the position here. We can see these very large commutators here. I think that there is a solenoid inside which permits to keep this selector in position. And we can see that there are two wires which penetrate inside this cylinder stuff, one here and a second one in the opposite side. There is a resistance of 170 ohms. I have connected this solenoid to a power supply. Currently the power supply is not activated. Let's activate the power supply. Okay, you can see that the switch remains in that position, and I am going to turn off the power supply. And here we have two relays, a few resistors, and two diodes here. This is a nice module. Next item is this audio control unit. We have two nice push buttons. Manufacturer is Clar, made in Belgium, dot code 80 something. And there is a rotary switch here and two other selectors. And we can see that we have two electronic boards. The first one here is a relay board, and there is another electronic board here. I have done the reverse engineering of this board. Let's have a look on the schematic. Now we can see here the schematic of this board. There are two inputs here. There is the first amplifier with a gain of 5.6, and these two outputs are fed to a first IC. The reference is CN617T. I didn't find the datasheet of this part. And the output here is fed to another part through this potentiometer. So this part seems to be a kind of op-amp, and the output is fed to this transformer here. The board is supplied with a voltage of 12 volts. We can see here the voltage regulator 2812. I have connected this board to an oscilloscope, and one input is connected to a function generator. This circuit is actually an automatic gain control, which works very well. At the output here, there is an RMS voltage of 3.3 volts approximately 10 volts peak to peak here. The input is connected to a function generator. Currently, the amplitude is 1 millivolt RMS. I will change the input amplitude 2 millivolts, 10 millivolts, 20 millivolts, 50 millivolts. You can see that there is a distortion, and 100 millivolts, 40 millivolts. So we can see that the amplitude is constant for an input voltage ranging from 1 millivolt to 40 millivolts approximately. Let's have a look at the bandwidth. Currently the frequency is 1 kHz. 2, 3, 4, 5. At minus 3 dB, the bandwidth is approximately 15 kHz. Frequency is 200 Hz. And also it is probably the limit also for the automatic gain control, 400 Hz. So it seems that the minimum frequency is 400 Hz. This is a square wave at 3 kHz. Here we have the relay board. We have also this small transformer. It is probably an audio transformer. So this is a switch that code 8028. There is another switch here. And we have this rotary switch, 4 positions, 4 circuits. It can be reused for something else. And this old voltage regulator, SFC 2812RM. The third item is this control unit, nav attack. NSN reference was erased here, I don't know why. Serial number 160. This thing was made by Ferranti, Scotland. There is a document here. This one was for training use only. There is here a circular connector, and on the front there are several controls. We can see that this rotary switch has actually different modes. Here it is locked. You need to push the knob to enter mode A here. iNav. Align, you need to push one more time. Standby off. Standby and a GT. Here we can insert a module which is missing, unfortunately. There is a DTX push button, several annunciators. There is here a selector for alignment. It is time for teardown. There are a lot of screws. We can see several electronic boards. It seems that some are not populated. Now this board seems to be a prototyping board. It is called the panel, a printed circuit. Okay, so it seems to be, yeah, it is the same board, but this one is populated. It's a kind of prototype. It is called a converter switch logic. I guess that we have here several gates using diodes. This one is more interesting. This one is a lamp driver. So there are several logic ICs. These transistors permit to activate the lamps. We have here 4 quad comparators, and here we have several logic ICs, 54 series. This part is a resistor array, 4.7 kilo ohms. There is a 54 174, so this is a quad D flip-flop. And here we have a 5406. This is an inverter with open collector. And here we have an LS123. And this is a monostable. We have here some pass-through capacitors. There is here a voltage regulator in TO3 package. And we have here the front panel. We have here 2 nice rotary switches. We can see here the connector for the lighting. And here we have the female connector. The next and last item is this one, maybe the most interesting. This thing is a control switch unit. We can see that we should find a microcontroller or microprocessor inside. There is a program identification. On the rear there are 5 connectors. On the front there are several push buttons and an on-off switch here, standby bit, stop, and so on. Let's start by removing the top cover here. Very nice, look at that. We have a stack of 2 boards here, and there is another module, or maybe the power supply. We should find 2 FPGAs here, or 2 ASICs, I don't know. Some parts are not populated. And here there is maybe a EEPROM, but I'm not sure. Yeah, this is an EEPROM, effectively. Okay, so there is here another digital board. Okay, so we have an NSC 800 processor. And there is here an NSC 810. This is a peripheral. It has the input, output, counters, and other things. And here we have drivers for an RS422 interface. And we have here an 82C52. And we have here a quad op-amp. And here we have a part from Analog Devices, SW06. And here it is difficult to see, it's an AD75 something, so this is the DAC. And here we have a voltage reference, an AD580 4, I think. We have an OP 200. This is a dual op-amp. And here we have an EEPROM which contains the code of this microprocessor. And we have a PAL here. So this is a very nice board, very well constructed. And we have here a DC-DC converter from Pulse. We can see here a TVS diode. So therefore the power supply input should be in parallel to this diode. There is maybe a protection diode in series with the power supply, and maybe this one here. Okay, we can see that this material should be dangerous. It is maybe beryllium oxide. It seems that we have only one regulator here. Now this is the keypad assembly. Now we can see that we have several relays on that board.